Welcome to the Test 3 review session for Chapters 5 and 6 for Intermediate Algebra. And what I wanted to do was first show you how to get to your Test 3 review in the course. So I'm in the course now as a student, so remember you get to everything through modules. And so you would want to scroll all the way down to, there we go, Test 3 module, Chapters 5 and 6. So we have an overview page that just tells you what to expect on this test. So this test is going to cover Chapters 5 and 6. You can use a graphing calculator as you can on all of your other tests. It must be a handheld graphing calculator, and you may not use any notes on the test, so nothing has changed in regards to that. You must take the test in a Valencia College Testing Center, and it is your responsibility to know the testing center's days and hours of operation. So you can look through here and see what you could expect to know for your test. So just like the last test, we have a test review that's basically problems similar to what you can expect on your actual test, and you have unlimited attempts on that test review, and the average is a lab grade. So that's what this first assignment is here. Next we have a practice test. So I provided a practice test that looks very similar to the actual test that you can use to practice taking the test. So if I were you, I would practice placing yourself in kind of a testing environment. Don't have your notes out, turn your phone off, only have your graphing calculator and some scratch paper, and try to work through an entire test within the 2 hours and practice going through that motion of actually taking the test. So I would use the practice test for that, but that grade is not saved. So if you just know that that's just for you to practice testing, but the actual test review, which says lab grade beside it, will be counted as a lab grade. And I just have some helpful tips and suggestions for how you use a practice test and then good test-taking strategies. So what I'm going to do today is work through a test review. All right, so this is what it will look like for you. So it looks kind of like a homework set, but it's problems similar to what you can expect on your test. All right, just like for your homework, you've got 3 attempts per question until you get the answer, and then if you want to try again, you can just try again and keep, trying a new problem that's very similar to get full credit. So you do have limited attempts to get a 100%, but after 3 attempts per problem, I'll give you the answer, or you could jump to the answer right away. Like say for this problem, you want to know what the answer is right away. You don't know what the answer, or you're confused. You can say jump to answer. It will give you the answer, and you can't answer it now yourself, but you can then try a similar question and then try it again. All right? So I just wanted to show you where this stuff was. Also, just now that you're here, we're talking student feedback of instruction. Please do that. Number one, if I get 90% of you guys to do the feedback for this course, then I will drop, I believe I said, a quiz grade and 3 homework grades. It'll take you no more than 5 minutes to do this feedback for the course. It's really helpful for me and the college to get feedback for me as your instructor and this online course. Yeah, that's pretty much it. So let's get started. I'm going to leave from this screen and open up the review. So these problems are going to be also written out or typed out like you would see them on the actual test. I can talk about how you get your answer and things like that. So for number 1, simplify 3 times the 4th root of 243 times x to the 15th completely, and then write your answer in radical form. So let's start with the 4th root of 243. Okay? So if you want, you can use your calculator to see if that's a perfect 4th. So let's do that. just to show you you can do that. So in order to use the calculator to do that, I want to do the fourth root, so I will go to Math, and then I will, actually before I do that, I want to type 4 to show that's the index number, Math, and then choose this fifth option here, and then we're going to put 243. Okay, good. So that tells us that 243 is not a perfect fourth. Okay? That's okay. So let's now see what we can do from there. So I need to think of two numbers. So there's two ways you can do this. If you know your perfect fourths, you can think of, okay, which of those perfect fourths? So 1 to the fourth, 2 to the fourth, 3 to the fourth, which of those numbers are factors of 243? Or you can do a factor tree to reduce that as well. So for example, let's see, 243 divided by, I don't know, 3 equals 81. So I can use 3 and 81 to start simplifying this radical. So let's do that. If I have the fourth root of 243, I'm going to break that down into 3 times 81. And I'm going to keep doing that until I have all prime factors. So 3 is prime, I can stop there. 81 can be broken down to, say, 9 times 9. And then 9 can be broken down to 3 times 3 and 3 times 3. So what this tells us is that the fourth root of 243 is the same thing as the fourth root of 3 to the fifth. 3 times 3 times 3 times 3 times 3. How do we reduce that? Well, okay, 4 goes into 5 one time, so I'm going to have 3 to the first on the outside, and I'm going to have how many left over? 1, so I have 3 to the first on the inside. Okay? Another way you could think about that is by saying, okay, the fourth root of 3 times 3 times 3 times 3 times 3. So I have 4 3's here. So that's going to come out of the radical. And then how many are left over? Just one of them there. Okay? So what's going on? I still have this first 3 on the outside. That was always there. Now I have times 3, the 3 from this, then it's the fourth root of 3, and I still need to deal with that x to the 15th now. Okay? So now, 3 times 3, I can go ahead and multiply, is 9, and so now I have the fourth root of 3, x to the 15th. Okay, now let's take care of this fourth root of x to the 15th. So 4 divides into 15 how many times? 3 times, because 3 times 4 is 12. So x to the third will be outside of the radical. But when I do that, how many do I have remaining? I have 3 remaining. So x to the third will be under the radical. Remember that 9 is still on the outside, and then this 3 is still under the radical. So my final answer is 9x to the third times the fourth root of 3x to the third. I know that I can't further simplify the fourth root of x to the third because the 4 index is bigger than this x to the third exponent. So remember, when you put this into the system, you want to make sure that you put that correct index number. Alright? Let's see if I can pull up an example on IMath AS. It's not going to be the same question, but it can at least review. So now remember, use this yellow arrow to help you input your answer. So you don't have to even do this whole root parentheses 3, you don't have to even type that anymore. That's old. You can use this to put your answer in there. A third root, make sure that you do that. So if you want to say 7 times the third root of whatever. I'm just going to retype what it says. You want to select this, the nth root. Oh, it automatically gives you the 3? Oh, okay, and you could change it. So if you want to say fourth root, you could put 4. It automatically said 3, and then you can type whatever you want. And then say save, and then it'll pop up here, and you can read right here to make sure it came out how you want it to be. But like if you were to say the square root, say you were typing it and you said the square root of something, that's not the same thing. So just pay attention to that when you're doing these problems. Okay? Alright. So I'm going to work through a few problems, not the whole thing, but just kind of touch on some topics that you'll see. So for this problem, we have 1.736 times 10 to the negative 76 divided by 2.8 times 10 to the negative 36. So let me kind of show you a hack for this problem. Use your calculator. Alright, if we use the calculator, let's say 1.736 times 10 raised to parentheses negative 76 close parentheses. Enter. That E is the scientific 10 to the base of 10. So we're dividing that by parentheses 2.8 times 10 raised to negative 36. Enter. So your calculator actually gives you your answer. 6.2 times 10 to the negative 41. You can also do it like this. So if we divide in our calculator 1.736 divided by 2.8, we're going to get 0.62 times, now if you look here, think of your exponent rules. So we are dividing exponents with the same base. That's going to be 10 to the negative 76 minus negative 36. You subtract your exponents. So negative 36 minus negative 76 minus negative 36 is going to be negative 40. So that's going to be 0.62 times 10 to the negative 40. Now, this is not in scientific notation because this number must be between 1 and 10. So we would have to move that decimal one place to the right to make that 6.2. Okay, so by moving that decimal 1 to the right, if we move the decimal to the right, we are making a number, we need to compensate for that by multiplying it by 10 to the negative 1. So that means here 10 to the negative 40 times 10 to the negative 1, we would add the exponents. That would be 10 to the negative 41. So that's how we can get our answer using, doing it by hand. Or the hack is you can use the calculator as well. Okay, number 3. Try to evaluate negative times negative 36 raised to the 3/2. Alright, so this exponent of 3/2, the base is parentheses negative 36. Okay? So that is the base. Now remember, if you have a rational exponent, the bottom number is the index, and then the top number is the power. So that means this would be negative, this is the first negative, times the square root of negative 36 raised to the third. Now, if we do that, if we look, can we have the square root of a negative number? This is not real. Now, we do know now how to deal with imaginary numbers, complex numbers, but it says to enter does not exist if the number is not real. So because of this situation here, you cannot have the square root of a negative number. That's an even root. We can't have an even root of a negative number, so that means that the answer does not exist. Let's look at another example. Try to evaluate negative times negative 27 raised to the negative 4/3. So we've got, first of all, when you have a negative exponent, you want to immediately make that exponent positive. So this is going to be, this first negative is still here. And so we want to make this exponent positive. So we're going to move it to the bottom, negative 27 raised to the positive 4/3. And since we need something to put at the top to kind of be a placeholder, we'll just put a 1 there. Okay, so now, let's see, we have negative 1 over. So now we have the third root of negative 27 raised to the 4th power. So we still have that negative 1 in the numerator. So the third root of negative 27, that's going to be negative 3. Okay? Because negative 3 times negative 3 times negative 3 is negative 27. And we still want to raise that to the 4th power. So now, negative 3 to the 4th power is going to give us positive 81. But our final answer is going to be negative 1 over 81. Okay? But remember, when you are taking a radical exponent, a rational exponent and changing it into radical form, when you have a negative exponent, you want to make that positive immediately and then rewrite it into radical form. Okay, number 5, perform the indicated operation. So before we just went from rational exponent form into radical form, well, now we can go from radical form into rational exponent form. So right now we cannot put them together. And why can't we do that? Because we have 2 different indexes. So we can't do this. All right? So what can we do? What we can do is rewrite each of these radicals into rational exponents. So this numerator is going to be y to the 1/4 divided by, the denominator is y to the 1/5. So now we have exponents and we're dividing and they have the same base, so we can simplify that. So we're going to subtract the exponents. That's going to be y to the 1/4 minus 1/5. And so to subtract exponents, you must have a common denominator. So we have 4 and 5. Let's make that common denominator 20. So 4 times 5 is 20. So 1 times 5 is 5. And then 5 times 4 is 20. So 1 times 4 is 4. So we can now subtract those exponents because they have common denominators. So we're going to keep that denominator and combine the top. So your final answer is going to be y to the 1 over 20. And they want you to write your answer using rational exponents. So remember, a rational number is like ratio, rational. So it's like a fraction. So you don't want to go back and write that as the 20th root of y. It doesn't need for you to do that. They want your answer as a rational exponent, and that's what we have here, y to the 1/20th. Okay, number 6, perform the indicated operation and write your answer using rational exponents. So here we're going to we have y to the 5/9 times this binomial of y to the 2/9 minus 4 y to the 3/9. So we're going to distribute this y to the 5/9 with each term. So we have y to the 5/9 times y to the 2/9 minus, multiply it again, y to the 5/9 y to the 3/9. When we are multiplying exponents with the same base, we'll add the exponents. So we have y to the 5/9 plus 2/9 minus, let's put this 4 in the front as the coefficient, y to the 5/9 plus 3/9. So now we already have common denominators. This is great. So this will be a lot easier to finish. So we're going to have y to the 5 plus 2, which is 7/9, minus 4 times y to the 5 plus 3, 8/9. And that's going to be your final answer. So if you need to refresh those exponent rules, you want to be sure and do that. Okay, simplify completely. So now we have radicals. It's kind of similar to what we did in the first problem, but we're going to then do operations with them. So in order to subtract or add radicals, you must have like radicals, just like having like terms. We do not have like radicals because you have to not only have the same index, which we do have, we have to have the same radicand, the same thing under the radical. And we don't. This is x to the 7th, this is x to the 3rd. So before we can do any combining, we want to see if we can get like radicals. Let's look at the first one. So the 4th root of x to the 7th. Can 4 go into 7, divide into 7? Yes, it can. 4 divides into 7 one time. So we're going to pull the x to the 1st outside of that radical. And what's the remainder? Well, 3. So we're going to have the 4th root, x to the 1st, or just x, times the 4th root of x to the 3rd. We still have this 10 outside, minus 4x times the 4th root of x to the 3rd. So now if you look, we do have like radicals. See? So think of it as like terms. So we're going to keep that the same there, the 4th root of x to the 3rd, and then we're going to just combine the outside. So we have 10x minus 4x times the 4th root of x to the 3rd. And then what's 10x minus 4x? Well, that equals 6x times the 4th root of x to the 3rd. And that would be your final answer. Let me write that again. 6x times the 4th root of x to the 3rd. So multiply and then simplify completely. So we have a binomial times a binomial. So we're going to distribute. So we're going to say 6 times negative 10, and then 6 times square root of 6. So that would be 6 root 6. And then we've got square root of 6 times negative 10. So that's going to be negative 10 square root of 6. And then the square root of 6 times the square root of 6 is going to be the square root of 36. So 6 times negative 10 is negative 60. We have like radicals here. So 6 minus 10 is negative 4. And then we still are going to keep that square root of 6. And then the square root of 36 equals 6. So now we have like terms here, negative 60 plus 6. So negative 60 plus 6 is going to give me negative 54. And then I still have that minus 4 root 6. And then I cannot break down the square root of 6 further because the only factors for 6 would be 1, 6, 2, and 3, and we can't, there's no perfect square that's a factor of 6. So this would be our final answer. Negative 54 minus 4 root 6. Also remember, you cannot combine negative 54 minus 4. This is not just negative 4. This is negative 4 times root 6. So you can't like try to combine that. That would be a no-no. That would be wrong. Get this one. So we're going to do the same thing. We're multiplying binomials. Let's see what happens when we... Now let's go back here. Let's observe what happened when we multiplied two radicals. Whoa. That had this, two of the same radicals. So when we did the square root of... do it over here. The square root of 6 times the square root of 6. That was the square root of 36, which equaled what? 6. So that's a cool property. If you multiply two of the same square roots, the square roots just cancel and you end up with that same radicand. So for example, if we said the square root of x times the square root of x, that would give us x. The square root of 2 times the square root of 2, that would give us 2. So that's helpful to know for this next problem. Okay, so when we distribute here, let's see what happens. So the square root of 3x minus 2 times the square root of 3x minus 2. Instead of writing that all out, what are you going to be left with? Just 3x minus 2. Right? Okay. Then we have the square root of 3x minus 2 times negative 4. That'll be negative 4 times the square root of 3x minus 2. Then 4 times the square root of 3x minus 2 would be plus 4 times the square root of 3x minus 2. And then 4 times negative 4 is negative 16. So let's look and see what's going on in the middle here. We have negative 4 root 3x minus 2 plus 4 root 3x minus 2. So these are like radicals. Whoop, I didn't mean to do that. These are like radicals here. So just combine the outside. Negative 4 plus 4 is 0 times square root of 3x minus 2. So 0 times anything is going to be what? 0. So basically these cancel out. So what I have left with is 3x minus 2 minus 16. And I have like terms here with negative 2 minus 16, which will give me negative 18. So my final answer is just 3x minus 18. For number 11, let's talk about rationalizing the denominator. So we have a square root in the denominator, and you don't want to leave a problem like that. So what you're going to do is what's called rationalizing the denominator. So in order to do that, we're going to take the denominator and multiply the top and bottom by the conjugate. Okay? So the conjugate of 4 plus, that's what I'm talking about. Whoa. Okay. The conjugate. So the conjugate of 4 plus square root of 7 is 4 minus the square root of 7. So we're multiplying the top and bottom by that. So at the top, I've got 27 times 4 minus the square root of 7. And on the bottom, I've got 4 plus the square root of 7 times 4 minus the square root of 7. So let's see what's going to happen. At the numerator, I'm going to distribute this 27 with 4. So 27 times 4 is 108. And then 27 times negative root 7 is negative 27 root 7. In the denominator, we're going to FOIL 4 times 4 is 16. 4 times negative root 7 is negative 4 root 7. Root 7 times 4 is positive 4 root 7. And then root 7 times negative root 7 is going to be negative root 49. So let's see if our radicals go away in the denominator, because that's the point of this. So the top part I have 108 minus 27 over, well, minus 27 times root 7. And the bottom, 4 root 7 plus root 7 cancels out. So I'm going to have 16, we use black, 16, and then what's the square root of 49? 7. So I have minus 7. So what is 16 minus 7? 9. So I have 108 minus 27 square root of 7 all divided by 9. Now you want to make sure you reduce all the way. So you have to see if these three numbers have a common factor. And there is. And you can always look. Here's the best way to do that. You can take your calculator if you're not sure on how to figure that out. And then we are going to, we have 108, 27, and 9. Let's see. Well, we know that factor of 27, we can take 27 divided by 9, you get a whole number. And then 108 divided by 9 is a whole number. So we can divide 108, 27, and 9 by a common factor of 9. So if we divide them all by 9, 9 goes into 108 12 times, 9 goes into 9 1 time, and 9 goes into 27 3 times. So our final reduced answer will be 12 minus 3 root 7 over 1. So we can just write this as our final answer. 12 minus 3 root 7. And you want to reduce. If you don't reduce it, you won't get your full credit. Number 12, solve the radical equation. So to solve this radical equation, when you're solving a radical, you want to get one of your radicals by itself, isolated, and then to undo a square root, we're going to square it. So this problem is already set up for us to go ahead and get started. So let's say I want to get rid of this first square root on the left. I'm going to square it. Now if I square the left side, I have to square the entire right side. Now when I do that on the left, what's going to happen is that your square root is going to drop with the square. That was the whole point of doing that. So on the left, I'm just going to have 41 minus 2x, because that was the whole point of doing it. But on the right, that's not what I'm going to have. On the right, I'm going to need to write that out and FOIL. So that's going to be the square root of 9 minus 2x plus 4 times the exact same thing, because that's what that means, right? So the left side is going to kind of hang out while we work on this right side. So on the right, I'm going to FOIL. So the square root of 9 minus 2x times the square root of 9 minus 2x. And remember what we said, we're multiplying two identical radicals, so I can just drop the radical sign, the square root, and just write 9 minus 2x. Alright? And then next, 4 times square root of 9 minus 2x will be 4 times square root of 9 minus 2x. Then on the inside, same thing, 4 times square root of 9 minus 2x. And then last, 4 times 4 is 16. Remember, the left side is just kind of hanging out. So let's see if we have any like terms we can combine. So I've got a few on the right. So let me just rewrite the left side. So on the right, I've got 9 plus 16. 9 plus 16 is 25. Okay, I'm going to cross that out. Now I'm going to bring down that minus 2x, cross that out, and then I have like terms in the middle. So that's going to be 4 root 9 minus 2x plus 4 root 9 minus 2x, which is going to give me plus 8 root 9 minus 2x. Those are your like terms. Okay? So now what our goal is now is to eventually get this square root by itself so we can square that side and then eventually get rid of all the square roots. So to start that, I'm going to move everything except for the term with the square root to the other side. I want to get that square root by itself. So I can, let's see, I can subtract 25 on both sides. I'm going to subtract it from the 41. And then I can add this 2x to both sides like that. Let's see what happens. So 41 minus 25 is 16. Negative 2x plus 2x cancels. 25 minus 25 cancels. That cancels, and I have 8 square root of 9 minus 2x. Let me write that 16 a little closer. Okay, so remember the goal is to get this by itself. It's not isolated yet, but if I divide the 8, then it will be, because I'll have 2 equals square root of 9 minus 2x. Look at that. Got it by itself. So now that I've finally gotten to that point, what I can do now is square this so that the square root and the square will cancel out. But it's an equation, so if I square the right, I have to square the left. Luckily, squaring the left is easy peasy. That's just 2 squared, which is 4. I'm going to write. So that's 4 equals the square root and the square cancels out, 9 minus 2x. And we're almost done. I want to solve for x. So to do that, I'm going to move this 9 to the other side. So 4 minus 9 is negative 5 equals, bring down that negative 2x, and then finally divide by negative 2 to solve for x. So negative 5 divided by negative 2 is positive 5 over 2, which equals x. And then that's my final answer. Now, you can always check your work to verify that you have the right answer. And let me show you how you can do that. We have that x equals 5 over 2. So let's check. So on the right, I've got the square root of 41 minus 2 times 5 over 2 equals the square root of 9 minus 2 times 5 over 2 plus 4. So, let's see. The 2's cancel. I'm going to have the square root of 41 minus 5 equals the square root of 9 minus 5 plus 4. So 41 minus 5 is 36. So the square root of 36 equals 9 minus 5 is 4. So the square root of 4 plus 4. Okay, what's the square root of 36? 6. What's the square root of 4? 2 plus 4. And lo and behold, 6 equals 2 plus 4, which equals 6. So yes, all that hard work has paid off. We have the correct answer. Please, please, please take the time to check your work. It will help you in the long run. It can never hurt you. That's another reason why it's good to do the practice test and practice kind of timing yourself, because you have more time than you think. A lot of you finish your test and you have like an hour and 15 minutes left over before you finish it. You could have checked your answers. I don't think you realize how much time you have left. So check your answers. Okay. Number 13, evaluate the expression -5 plus 3i plus 4 minus 5i and write your answer in the form a plus bi. So these are talking about complex numbers with the imaginary number I. And I is a number in this case, but when we are dealing with the expressions with I, think of it like a variable. So when you add these binomials, you can just drop the parentheses and combine like terms. So -5 plus 3i plus 4 minus 5i. So I have like terms with the -5 and the 4. So -5 plus 4. And then I have like terms with the 3i minus 5i. So -5 plus 4 is -1. And then 3i minus 5i is -2i. And that's your final answer. So just think of them as if they are, the I is a variable x, and just combine your like terms for these. So perform the indicated operation and simplify. So we're going to distribute this 4i with this -6, and then distribute 4i with positive 3i. So let's see what happens now. So 4i times -6 is going to give me -24i. Then 4i times 3i is going to be 4 times 3, 12. And then I times I is I squared. Now, something very important for these problems. I squared, that has a value. So I equals the square root of -1. And so remember, you can't take the square root of a negative number. We kept saying that's not a real number. It's not, it's an imaginary number. So the square root of a negative is going to give you I. So that means that I squared would be I squared equals -1. This is super important to remember, because whenever you see an I squared, you want to replace it with its value of -1. Alright? So what we have is -24i plus 12 times -1. So what we actually have is -24i, and then 12 times -1 is -12. And so we normally write a as we write the constant as the first number, so we'll say that's -12 minus 24i. But I don't think it really matters for these, but just so you know, this is how you want to write it. Factoring. So in order to do that, we need to set our equation equal to 0. So to start that, let's add 5x and subtract the 20 on both sides. So I'm going to have 2x squared. -2x plus 5x is 3x. And then I have -20 equals 0. Now we're going to factor this trinomial. So let's take the AC method, because we don't have a greatest common factor to factor out. So 2 times 20 is 40. So we need two numbers that will multiply together to give us 40, and subtract, because the 20 is negative, to give me 3. Okay? So that would be 8 and 5. Now let's set up our factors first. So the way that I'm doing this, I'm going to start off by setting it up like this. And I'm going to drop the first sign and then multiply these two signs together to give me the next one. So now I have my two factors, 8 and 5. 8 times 5 is 40, which I got from 2 times 20. And then the difference between 8 and 5 is 3. So I want to always put the bigger factor first. So 8 and then 5. Now, we have to take our A, which is 2, and divide it like this. And then simplify, and then if you still have a fraction, we're going to slide that denominator to the front. So for example here, 8 over 2 can be reduced to 4. So that's going to be x plus 4. But over here, negative 5 over 2, we can't reduce that further. So we're going to take that 2 and bring it up here. So it's going to be 2x minus 5 equals 0. So now that we have factored it, to solve it, we're going to take each factor and set it equal to 0. And then solve. To solve the first one, we'll just subtract 4 from both sides. So x equals negative 4. On the next one, we're going to do a few more steps. We're going to start by adding 5 to both sides. So I have 2x equals 0 plus 5 is 5. And then to solve for x, I'm going to divide by 2 on both sides. So I have x equals 5 over 2. So my solutions are going to be x equals negative 4 and positive 5 over 2. Next, let's solve using the square root method. So we want to get rid of this square, so we're going to start by taking the square root on both sides. So on the left, the square root and the square will cancel, and I'll have x minus 8 equals, now I'm solving an equation and I'm taking the square root to solve for x. We want to include plus or minus the square root of 144. So don't forget that plus or minus. So now, let's see, the square root of 144 is 12. So I have x minus 8 equals plus or minus 12. And so now to solve for x, I'm going to add 8 to both sides. And what I have is x equals positive 12 plus 8 and negative 12 plus 8. So I'm going to have two different solutions. 12 plus 8 is 20, and then negative 12 plus 8 is negative 2. So my two solutions, x equals negative 2 and 20. Something else to keep in mind, this is a quadratic. It has a leading power of 2. That's your degree. That also tells you how many solutions you'll have. So that explains why you have two solutions here as well. Let's solve this equation by using the quadratic formula. So I've written the quadratic formula here. And so it's negative b, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so where is a, b, and c coming from? That's coming from your standard form of a quadratic. So we have a, b, and c. So the equation given here is x squared plus 8x minus 4 equals 0. The coefficients of the terms is going to give you your a, b, and c. So your a is going to be the one that you don't see in front of the x. So let me just put a 1. And then the b is 8. And then c is the negative 4. So a equals 1, b equals 8, and c equals negative 4. So this little part here has solutions a and b, where a is less than b, and that's just how it's going to look in IMathAS. So you have to put, you're going to get two solutions. You're going to put the smaller solution in for a and the next one in for b. That's just like how you input your answer. But this a and b is not the same a and b as what I'm talking about in the quadratic formula. Okay, let's plug everything in. X equals negative b, which is negative 8, plus or minus the square root of 8 squared minus 4 times a times c, all divided by 2a, 2 times 1. So we've got negative 8 plus or minus. That plus or minus is going to give us our two different solutions. The square root of 8 squared is 64, minus 4 times 1 times negative 4 is positive 16. Alright? Okay, So all divided by 2. So now you have negative 8 plus or minus the square root of 80 divided by 2. And then in IMathAS, they want it in decimal form. So you can very easily put this in your calculator and get your decimals. So the first one, first solution is negative 8 plus the square root of 80 divided by 2. And then negative 8 minus the square root of 80 divided by 2. So let's look at how you would put that in the calculator. So we'll start with negative 8 plus the square root of 80. I like to press enter, get the answer, and then say divide by 2. Okay, and I think it wants us to round to the nearest 3 decimal places. So we've got 0.472. Let's look at the next one. So we've got negative 8 minus the square root of 80. Enter, and divide that by 2. So we have negative 8.472. So those are your solutions. So let's see. So the first solution would be the negative one, because that's the smaller one. And then the second solution would be this solution. Okay? It also says you can enter it as exact expressions. So if you entered, if you knew negative 8 minus square root of 80, all that divided by 2, you could put that in as well. That's another option. Let me see if I can pull that one up. It's going to be a fraction, negative 8 plus the square root of 80 divided by 2. And then say save. Then it would, also give you your answer that way. So that's another way you could put your answer. But that's what this means. Give your answer to 3 decimal places or exact expressions. The square root is the exact expressions. Okay, for the next problem, we are looking at a word problem about a rectangle. So it says a rectangle, let's go ahead and draw that rectangle, is 4 yards longer than it is wide. So we'll say if this is x is the width, the length is 4 plus x. Find the dimensions of the rectangle if the area is 140 square yards. So the area of the rectangle is 140 square yards. So remember that the area of a rectangle is length times width. So for this, we're going to say 140 equals length 4 plus x times x. So now we're going to multiply 4x plus x squared equals 140. And then if we're going to solve this, we need to set it equal to 0. So let's subtract 140. So then I'm going to have 0 equals, let's write the right-hand side in standard form, x squared plus 4x minus 140. Okay, so now you want to, let me rewrite this a little neater, 140. So now you need to factor this trinomial, if it's factorable, or use the quadratic formula. And for this one, let's see, so 140, I need to get a difference of 4. I'm not sure if that's factorable. Let's just use the quadratic formula and practice that some more. So let's remember the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we've got a equals 1, b equals 4, and c equals negative 140. So we've got x equals negative 4 plus or minus the square root of 4 squared minus 4 times a times c, all divided by 2 times 1. So that's going to be -4 plus or minus the square root of 16. -4 times 1 times -140 is going to be 560 divided by 2. 16 plus 560 is 576. The square root of 576 is 24. So x equals -4 plus or minus 24 divided by 2. So that gives us two solutions, -4 plus 24 divided by 2 and -4 minus 24 divided by 2. So the first one will be -4 plus 24 divided by 2 equals 10. And then -4 minus 24 divided by 2 equals -14. So let's remember what this problem is asking us. So it's asking for the dimensions. So in this case, what was the width? X. The width was x. So that means that now we have two solutions, 10 and -14. We're talking about an actual scenario that involves dimension. So we don't want to include the negative solution. We just want the positive one. Okay? So that means x equals 10. So the width is 10. And then if the length is 4 yards longer than the width, then the length would be x plus 4 plus x, which would be 14. So make sure you know, so you want to label x represented the width, and then the length is x plus 4, or 4 plus x. So that way you can put the right answer in for the right spot. Let f of x equals x squared. And we want to write g of x so that f of x is shifted up 4 units, and then actually write that g of x formula. So let's just look at a basic function. F of x equals a times x minus h squared plus k. So this gives you a lot of information. This is actually in Vertex Form. So the h tells you how much you will move left and right, or shift left and right. And then the k tells you how much you'll move up and down. Okay? So if we start off with f of x equals x squared, and if we are shifting up 5 units, that means that's going to be our k. So in this case, we don't need to include a different h value. We don't need to change the a value, which is how you stretch or shrink your graph. All we need to do is say g of x equals x squared, and then say up 4 units plus 4. I'm going to do another example. Let's say that we shift 2 units to the right. Okay, so it'll be, I'll call it h of x. h of x equals, in that case that deals with the h. So it would be x minus, and then if we're going to go to the right 2, that's going to be a positive 2 squared, but we're not going to go up or down any, so that would be your formula for taking f of x and shifting it to the right 2 units. What if I said it went down, let's see, down 3 and to the left 1? What would that look like? So if we start with f of x equals x squared, so that means we have an h and a k we need to put into our formula. So we'll call this, I don't know, g f h t of x. So if we're going to go to the left one, that's 1 minus negative 1, because left 1 goes to the negatives, squared, and then if it goes down 3, we're going to say minus 3. But we don't ever want to have minus a negative, so the final function, I'm calling it t of x, would be x plus 1 squared minus 3. So I just wanted to go over a few examples, but the answer to the initial question is x squared plus 4. Okay, this is an example. This is an example. This is the original problem here. Okay, let's look at the next one. Now let's match the function with its graph. So we have y equals 3 times x plus 2 squared minus 4. So again, this is vertex formula for the quadratic. So remember that the vertex we get from what we call h and k. Why is my writing so bad? Okay. So what is h and k? So remember, it's coming from y equals a times x minus h squared plus k. So the vertex comes from the h and the k. So notice that the number you see in the parentheses, you have to change the sign to actually give you h, because it's x minus h. So for example, for this problem here, we have 3 times x plus 2 squared minus 4. So the vertex for this formula, this function, is going to be negative 2, comma, and then keep the k the same, negative 4. So to find the function that matches this graph, let's start by finding a function that has a vertex of negative 2, negative 4. So for example, for this first one, negative 2, negative 4 is here. So that's not the vertex for this given parabola. So we're going to cross that option out. Same thing as over here. The vertex for this parabola is negative 2, positive 4. We need negative 2, negative 4, so that cancels that. This one, negative 2, negative 4, that works. That's a possible. And the last one, the vertex is positive 2, positive 4, so that doesn't work. So this must be your answer. You would choose this graph here. And that's really all you need to know based on the graphs that you're given. So the vertex helps us determine which graph matches this function. Okay, now can we find the vertex when we are given it in standard form? So standard form is f of x equals ax squared plus bx plus c. And the way that we find the vertex of a quadratic function, we find the x coordinate of the vertex. And so to do that, we would say x equals negative b divided by 2a. And so for this function, a is going to equal 1, b is going to equal negative 3, and c is going to equal negative 28. So let's find our x coordinate of the vertex. So it's going to be negative b, so that's going to be negative 3, divided by 2 times a, which is 1. So that's going to be negative times a negative 3 is a positive 3 divided by positive 2. So the x coordinate is 3/2. Let's get the y coordinate. So to do that, you take your function and you plug in what you found for your x coordinate to get its corresponding y coordinate. So into your original function. So it's going to be 3 over 2 squared minus 3 times 3 over 2 minus 28. Okay, so we plugged in that x coordinate into each x term in the function. And so let's use the calculator just to kind of simplify this. And I want to just kind of show you how you can use the calculator to, use operations with fractions. So I'm going to say, clear all this out. 3 over 2. I like to put all my fractions in parentheses. Squared. And then minus. So I'm going to go ahead and say 3 times 3 is 9. That's going to be minus 9 over 2. So minus 9 divided by 2. Whoops. Minus 28. That's the decimal. And we can even get the fraction value by choosing math and choose fraction. We have negative 121 over 4. Let me see in the problem how they usually want you to write your answer. Let's see here. Doesn't really matter, but we'll do the decimal value. So we'll say negative 30.25. So 3 over 2 is 1.5. So this will be negative 30.25. And then we'll go ahead and, so that equals 1.5. It will be consistent and write the x coordinate in decimal form as well. So just to rewrite it so it's clear, 1.5 comma negative 30.25. Since we're talking about this, let me also show you how you can graph a quadratic and kind of check your work. So let's say I wanted to graph this quadratic and calculate the vertex using the calculator. So the way that you would do that is that you would go to y equals, and we're going to put in the quadratic here. So f of x is the same thing as y, so we're going to say x, here's the variable button here, x squared minus 3x minus 28. So I'm going to say graph, and then I can see my graph there. It's kind of big, well, zoomed in too much, so I'm going to choose zoom. And if you go down to the bottom, there's a zoom fit. That will actually make the window big enough to fit your entire graph. So I'm going to say enter. It's going to kind of zoom out so you can see it better. So your vertex is over here somewhere, but you can't tell just by looking at it, but the calculator can tell it for you. So you can calculate this button here. We're going to say second trace. So we can calculate a ton of things here, but let's calculate the vertex. So if you think about this graph, it was a parabola facing up, so that means your vertex would be at the bottom, the most minimum y value. So we want to calculate the minimum. Okay, so we want to calculate. If this vertex was facing, if this quadratic was facing down, we would calculate the maximum to get the vertex. So we want to get the minimum here. So I'm going to choose that third option. So what it's doing now is it's asking you to kind of set the boundaries so the calculator knows where to focus. So I want to say this is the left bound. I'll press enter. You want to go anywhere on the left side of the vertex, and then move the cursor over anywhere on the right side of the vertex and press enter. So you see these little notches here? They're kind of helping you focus in on where you want to focus. The calculator wants to focus. And now it's asking you, do you want to guess or calculate? And you want to say, yes, I do want you to do that. So you're going to press enter. And then it actually calculates that minimum or that vertex for you. And so you see here it's got 1.499999. You can go ahead and round that to 1.5. And then the y-coordinate is negative 30.25, which is what we found by doing the algebra. So this is a really good tool, and you can use your graphing calculator on this test, but it's a really good tool to double check your work. You can do a lot with quadratics in your calculator in this particular section. Okay, so 24. A person standing close to the edge of the top of a 64-foot building throws a ball vertically upward. The quadratic function h of t equals negative 16t squared plus 120t plus 64 models the graph's height from the ground. Models the ball's height from the ground. I can't read today. H of t in feet, t seconds after it was thrown. What's the maximum height of the ball, and how many seconds does it take until the ball hits the ground? Let me sketch what's going on. So we've got a 64-foot building. The person is standing like here. And then they are going to throw a ball vertically upward. So they're going to throw it up, and it's going to eventually drop, right? This is the ground where the height is 0. So the person throws the ball up, and the ball's going up and it comes back down, right? And it's going to eventually land when h of t equals 0. Now, the question is, what's the maximum height of the ball? It's trying to get what is the y-coordinate of the vertex. That's what this is, the y-coordinate of the vertex. And then B is saying, well, how many seconds does it take until the ball hits the ground? It's trying to ask, well, if this is h, the height, and then this is t, this would be when t equals 0. No, when the height equals 0. Sorry, this is when the height equals 0. What does t equal? Okay? So we're going to, so for this we want to solve quadratic to find basically like the x-intercept as well. And it has to be the positive one. So you'll probably get a negative one because that would be, like if we were to continue the parabola, that would be over here. But this is where the time starts. T equals 0 here. It's asking basically what's t when it gets over here. Okay, so I'm going to need this to kind of do my work, so I'm going to erase some of this. Alright, so we want to get the maximum height of the ball. We got to first get the y-coordinate of the vertex. So we want to find the vertex. And so to start getting that, we're going to find x equals negative b over 2a. So that'll be negative 120 over 2 times negative 16. So that's going to give us negative 120 divided by 2 times negative 16. It's going to equal 3.75. And then to get the y-coordinate, h of t, so we're going to plug in 3.75 in for t. So it's going to be negative 16, 3.75 squared, plus 120 times 3.75, plus 64. So let's see here. I'm going to put all that in my calculator just so you can see how I would do that. So I would say negative 16 times 3.75 squared plus 120 times 3.75 plus 64. 289. So So 289 feet. That is the answer to A. Okay. Now it says how many seconds does it take until the ball hits the ground. So what you basically want to do is take your function, make your h of t 0, and solve it. Let's see. What can I factor out? I think this is factorable, or you could use the quadratic formula. I am going to show you how you can use the calculator to find your intercepts as well, just so you can know you have options. Okay, so how can I do that? Let's go back to y equals. Let's put our function in there. So I have negative 16 t squared. I'm just going to use x because that gives, it doesn't matter what variable we use, plus 120t, we'll put x, plus 64. Graph. Okay, so let's do zoom fit so we can see this better. Okay, so we want to, and actually, you know what I'm going to do? I'm going to make my window kind of mimic our picture. So we just need the minimum x value to be 0, right? Because that's like where we're starting from when time is 0. And the max, I don't know what the max will be. I'll just say 20 for 20 seconds. And then for the y minimum, well, the y minimum, let's make that's my height. The minimum height is going to be 0, the ground. And then the y maximum, well, we know we want it to be a little higher than 64 because it's going to go, you're going to throw it upward. Let's make, and oh, the height, the maximum height, oh, we know that it's 289. Let's make the y maximum 300. And then we should kind of see more of what we want to see. Good. Okay, so we want to figure out when does this graph hit the x-axis when the height is 0? Right here. So we're going to calculate. So your x-intercepts or your solutions, they're also called your zeros. So we're going to calculate the zeros. So we're going to say 2. And so it's asking you to set the left boundary. Bring this into when my y values are positive. There we go. Okay, so let's say this is the left boundary. And then this is the right boundary. See these little arrows here that's telling the calculator I only want to focus in this area here. Now I'm going to say guess. And look, it tells me exactly what my x value is when the is crossing the height of 0. So the answer would be 8 seconds. 8 seconds would be how long it takes for the ball to hit the ground. 8 seconds. And again, you can also get this by solving this quadratic. You'll probably get 2 different answers. And then the negative one you'd want to reject because that's not going to fit this scenario. But the positive one is the one that you would want. That's 8 seconds. Okay? And then I've got one more problem I want to look at. Okay. So consider the parabola given by the equation f of x equals negative x squared plus 8x minus 2. Okay. So first we want to find the value of f of negative 2. So let's do that. So basically we're going to plug in negative 2 everywhere we see x. So it's negative times negative 2 squared plus 8 times negative 2 minus 2. So that's going to be negative times 4 minus 16 minus 2. So negative 4 minus 16 is negative 20, minus 2 is negative 22. So f of negative 2 is negative 22. Now the vertex. To get the vertex, we're going to first find negative b over 2a, which in this case would be negative 8 over 2 times negative 1, which will be negative 8 over negative 2, which is positive 4. And then to get the y-coordinate, we're going to plug in 4 into the function. So we have negative times 4 squared plus 8 times 4 minus 2. So that's going to be 4 squared is 16 times the negative is negative 16 plus 32 minus 2. So negative 16 plus 32 is going to be positive 16, and then minus 2 will be 14. So that means your vertex is going to be 4, 14. Now for the y-intercept, you just want to plug in 0 in for x. So f of 0, whoa, it looks so messy. F of 0 would be negative 0 squared plus 8 times 0 minus 2. So that would be 0 plus 0 minus 2. So f of 0 is negative 2. So the y-intercept would be 0, negative 2. And then to find the two values of x that make f of x equal 0, you're going to solve this, set the whole function equal to 0, and we're going to solve this function. This is not going to be factorable, so you either would want to use the calculator or use quadratic formula. A equals negative 1, B equals 8, and C equals negative 2. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we're going to have negative 8 plus or minus the square root of 8 squared minus 4 times negative 1 times negative 2, all divided by 2 times negative 1. So that's going to give us negative 8 plus or minus the square root of 64. 4 times negative 1, negative 4 times negative 1 is positive 4, times negative 2 is negative 8, divided by negative 2. So that's going to be negative 8 plus or minus the square root of 56 over negative 2. We want to get decimal answers, so that gives us our two solutions in exact form. Negative 8 plus the square root of 56 over negative 2, and negative 8 minus the square root of 56 divided by negative 2. And you can put that in the calculator. So let's do that. So I'm going to start with the first one. So negative 8 plus the square root of 56. I like to press enter to get a value, and then directly after that say divided by negative 2. So that's going to be, and it said, I forgot how many times, wait, it's set to around 2 decimal places. So that'll be 0.26. So that would be the first solution. Let's look at the next one. So it's negative 8 minus the square root of 56. I like to go ahead and get a value for that by pressing enter, and then immediately say divided by negative 2. Enter, and then I'm going to round that 2 decimal places. That's going to be 7.74. And then it said to write the values as a list separated by commas, so you would basically write just that part there. Alright? Keep in mind that you cannot use a formula sheet, so you need to remember your quadratic formula by memory. Alright? So that's just a really
rough review of the type of topics and questions you'll see on your test. Do that practice, do that review as many times as possible to get more practice, and the practice test is for you to practice actually taking the test under testing situations. So that is the review. If you have any questions, just shoot me an email, and your test is due next week. But yeah, ask questions if you have them. Come down to the depot or any of the other tutoring centers at Valencia, and you can also use Smart Thinking, which is free online tutoring. But I will talk to you guys later. Bye!